All right, so some calculations. And I'll warn you, there are actually 3 videos on calculations because it's a fair amount. I don't think any of them are particularly difficult mathematically, but it's a lot to take in. So I definitely would recommend you might end up watching these videos a couple times. And again, as before, I try to lay out process step by step for you, so you have something to refer to. All right, so self-esteem and happiness. These data here represent some hypothetical scores for the relationship between self-esteem and happiness. See, we've got scores for 7 people. I've got a couple of formulas up here. The first one is, whoops, sorry. This first one here, that y prime equals a plus b sub y times x, that's just the formula for the regression line. How we derive b sub y, that's the place to start. How we derive the slope is we take our old friend the covariance which was in the numerator of the correlation, and instead of dividing by both standard deviations multiplied by each other, we square the standard deviation of x, or you also see this represented as the variance of x. So very close to what the correlation looks like. So it's a slightly different formula. This is on a completely different scale. This is on a scale that is not standardized. So this value can exceed 1. And then the y-intercept is simply the mean of the mean of y minus the slope times the mean of x. So again, these 2 formulas are mostly things that we've seen before. And I've given you the standard deviations and the means. I'll have those on other slides. But the first step here is to calculate the covariance. I know we just did that, but we can review it. So the first thing we do is take x minus x bar. For example, for the second person, their score is 20. Their mean is 23. So it's a value of -3. We do the same for the y values. And again, for the second person, their happiness score is 30. The mean for happiness is 35, so their score would be -5. And we do this for all of them. Once we've done that for all of the different scores, we multiply them together. And you can see I've multiplied them together, so I've got 70, 15, 34, and so on down the line. Once we have those values, the next step is to calculate the covariance. We basically are just summing that column of x minus x bar times y minus y bar, and that's our numerator. The denominator is 6, so the covariance comes out to 49.5. To get the slope, we just have to take that 49.5 over the standard deviation of x, which is 9.47, and square it, giving us a value of 0.552. And then the y-intercept is just a function of both means and the slope. So the mean of 35 minus 0.552 times 23 gives us a y-intercept value of 22.3. So that is the slope and the y-intercept. Slope, very much like the calculation of the correlation, only the denominator is different. Just to give you a sense, the y-intercept, our y-intercept was 22.3. If we look at a graph of our data, here's where x is 0, and we see that that's about 22.3. So that's just a numeric representation of what that point is on the line. Again, the slope, how much change we have in the line for every single 1 unit change of x. So from moving from 0, x of 0 to x of 1, we change about half a point, or 0.552 points to be very precise. You can see that graphically represented, how much that line is going up. You might see this a little better with a 10-point difference. If every 1 point is 0.55, then every 10 points would be 5.5. And you can see we move from about 20 to about 25.5 over here.